Hi everybody, I'm Miss Cooksey, and today we're going to be talking about triangle congruence. So the first thing we need to do is understand what the word congruent means. Congruent are geometric figures that have the exact same shape and the same size. So there's another word called similar, which are going to be shapes that are the same shape, so like a triangle and a bigger triangle, but they're not the same size. Congruent means same shape and same size. For two polygons to be congruent, all parts of one polygon are congruent to all the corresponding parts of the other polygon. So all of the angles and all the same sides that correspond, that are in the same place, are congruent. So for example, in these two polygons, there's a bunch of different pieces that are congruent. So angle A is congruent to angle E. We know that because they each only have one arc. Angle B is congruent to angle F. We know that because they have two arcs. Angle G is congruent to angle C, and angle H is congruent to angle D. We know which ones are congruent because of the amount of arcs that are in each angle. Next, we're going to look at congruent sides. So we know congruent sides because of the amount of tick marks. So side AB is congruent to side EF, side BC is congruent to side FG, and so forth. The congruent statement takes all of those angles and sides and makes sure that when we write that the two shapes are congruent, we put all of the angles and the sides in corresponding places. So here, polygon ABCD is congruent to polygon EFGH. Notice that A matches with E, B matches with F, C matches with G, and D matches with H. That's important. We want to make sure that all of the corresponding parts are in the same place in our congruent statement. When we know that two shapes are congruent, we can use it to solve equations. So here, triangle ABC is congruent to triangle MNO. Find the values of x and y. Well, let's find y first. So we're going to look at their sides. And we know that because the triangles are congruent, AC is congruent to MO. So we can write that as an equation. 32, the length of AC, is equal to 5y minus 12. We're going to add 12 on both sides, divide by 5, y equals 8.8. Now we can use that information to find the value of x. So we know that angle B is congruent to angle N. They're in the same place in our congruent statement. So that means 2x minus y is equal to 90. We know that y is 8.8, so we're going to add 8.8 to both sides, divide by 2, and x has to be equal to 49.4. We can then use this information to start proving that triangles and polygons are congruent. So there's something called the third angle theorem. We know that in a triangle, all three angles add up to 180 degrees. So the third angle theorem says if two triangles have two corresponding angles that are congruent, so if two of the angles are the same, then the third angle must also be the same. That's because if I have two triangles and the angles always add up to 180 degrees, if two of the angles are the same, the third angle has to be the same because it has to be that third angle that will add to 180 degrees. So the third angle theorem says that if two triangles have corresponding angles that are congruent, then the third angle of each triangle must also be congruent. There's also this rule called CPCTC. Blah, 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 blah. It's really hard to say. CPCTC says that corresponding parts of congruent triangles are congruent. So if I have triangles that are congruent, their parts must also be congruent. So let's look at this first example. Angle V is congruent to angle Z. So let's mark that. Angle V is congruent to angle Z. VW is congruent to ZY. VX is congruent to ZX. And my last WX is congruent to YX. We want to prove that the triangles are congruent. So we're given all this information. We already know that all three sides are congruent. So that's awesome. We're almost ready to prove it. The next thing we need to know is that angle VXW is congruent to angle ZXY. We know this because those two angles are vertical angles, and we know that all vertical angles are congruent. Now we have one angle, two angles. We have two pairs of angles in the triangles that are congruent. So we can now say that that third pair of angles is congruent because of the third angle theorem. Now I've shown that every single part of these two triangles is congruent. So that tells me that the triangles themselves are congruent because of CPC/TC. I have all of the corresponding parts in both triangles. They are all matched up and congruent. Therefore, the triangles themselves are congruent. Go ahead and try the next one on your own. Pause the video and then come back and check. Welcome back. Okay, so let's look at this next one. We know that angle J is congruent to angle P. We know that JK is congruent to PM. We know that JL is congruent to PL. And that's all we have in our given. We also know that L bisects KN, but we can't write anything until we've actually written that statement. So let's start with our vertical angles. So JLK is congruent to PLM because they are vertical angles. Next, we know, that LK is congruent to LM. One, two, three. 1, 2, 3. And we know that because that's the definition of a segment bisector. L bisects KM, and by bisecting, it cuts it in half and makes two congruent shapes. Last but not least, we know that K is congruent to M because of the third angle theorem. So we know that we have two pairs of corresponding congruent angles, so that third pair is also going to be congruent, which tells us that our triangles are congruent because of CPC/TC. That was a lot of work to prove that two triangles are congruent. There were a lot of pieces that we had to write out to prove. So next, we're going to learn some shortcuts. There are 4 shortcuts to proving that triangles are congruent. Side, 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 angle, and side, side, angle. Those are our 4 shortcuts. We're going to go through all 4. So the first is side, side, side congruent. Angles can be proven congruent when all the sides of one triangle are congruent to all the sides of another triangle. So if we can prove that all of the sides are congruent, then we can prove the triangles are congruent. Zoom out a little bit. So here, I'm given that AB is congruent to XY, BC is congruent to ZY, and AC is congruent to XY. I've got all those tick marks there proving that all of those sides are congruent. That tells me that the triangles are congruent because of side, side, side. The next one I'm going to have to fill in a little bit. So JK is congruent to LM, and JM is congruent to KL. Well, now we need to prove that this third side is congruent for both triangles, so that JL is congruent to JL. While this seems really obvious, we know that we have to write every obvious thing out in the proof. This is because of the reflexive property. The reflexive property is a property that we don't use very often, but it says that everything is equal to itself. Now I have proved that all 3 sides in both triangles are congruent, so I can prove that the triangles are congruent with side, side, side. So side, side, side is one of 4 methods. Let's look at the other 3. The next method is angle, side, angle. So the triangles can be proven congruent when two angles and the included side. So notice in this example how the side is in between the two angles and the side is in between the two angles. That's what angle side angle means. If one of the sides is outside of the two angles, then it will not work for angle side angle. The side has to be included or in between the two angles to prove that the triangles are congruent. So let's look at our examples. We have AD is parallel to BC, and angle BCD is congruent to angle ABD. So let's write that in. Angle BDC is congruent to angle ABD. Okay, so first up, we're going to say that angle DBC, which is this angle right here, is congruent to angle BDA because those angles are alternate interior angles. We have these two parallel lines and this transversal that goes through them. So these two angles are alternate interior and therefore congruent. Next, we're going to prove that DB is congruent to DB. That is, again, the reflexive property, that property that says everything is equal to itself. Now I've got two triangles that have corresponding angles and the side in between them, that included side being congruent. We can prove those triangles are congruent using angle side angle. Let's look at one more angle side angle, and then we'll move to our last two shortcuts. So we know angle E is congruent to angle H, and J is the midpoint of EH. Well, first, because J is the midpoint, I know that EJ is congruent to HJ because of the definition of a midpoint, and EJG is congruent to HGF. We know that these two angles are congruent because they are vertical angles, and we know that angles across from each other are always congruent. Now we have two angles and the included side being congruent, so we can prove that the triangles are congruent using ASA. Next, we're going to flip angle side angle. So we're going to look at side angle side. So side angle side says that if the two triangles are congruent, if the two sides and the included angle, so the angle in between those two sides, are congruent. So two sides and the angle in between those two sides are congruent. So here we have C is the midpoint of AD and C is the midpoint of BE. That's what's given to us. Well, we're going to start by using that to say that BC is congruent to CEC and AC is congruent to CD, and that's because of the definition of a midpoint. Then we have angle BCA is congruent to angle ECD. Again, these are our vertical angles, which we know are always congruent. Here we have side angle side, so we can prove that those triangles are congruent using side angle side. Last but not least, we have GH is congruent to FJ, and GH is parallel to FJ. That's what's given. So we're going to start by using the reflexive property to say that GJ is congruent to GJ. So now we have two pairs of sides. Now we need to prove that the angle in between them is congruent. And we can do that because we know that if GH is parallel to FJ, those angles are going to be alternate interior angles. Now the two triangles are congruent using side angle side, side angle side, side angle side. Last but not least, we have angle angle side congruence. The two triangles can be proven congruent when two angles and a non-included side of congruent to two angles and a non-congruent side. So angle angle side angle, angle, side. Let's look at a couple examples. So we have LQ is parallel to NP. So LQ is parallel to NP. KL is congruent to QN. So KL is congruent to QN. And LKQ is congruent to NQP. So the first thing we're going to do here is we are going to state that KQL is congruent to QPN. We know that those angles are congruent because they are corresponding angles. It's kind of hard to visualize, so I'm going to use my highlighter to help. But if we have a parallel line here and a parallel line here and a transversal here, then these two angles are corresponding. Now we can say that the triangles are congruent because we have angle, angle, side, angle, angle, side. Last one, we have angle A is congruent to angle C. Line segment A or line AD is parallel to line BC. Well, we're going to start with saying that angle ADB is congruent to angle CBD. This is because they are alternate interior angles. We know they're alternate interior because we have these parallel lines. Then we know that DB is congruent to DB. Because of the reflexive property. Next but not least, we know that the two triangles are congruent because of angle, angle, side. So angle, angle, side, angle, angle, side. And from that, we can then say that AD is congruent to BC because of CPCTC, that corresponding parts of congruent triangles are congruent. There was a lot in this video. We talked about what congruent means. We talked about how to prove that two polygons are congruent. We learned the basics of how to prove two triangles are congruent. And then we learned the 4 shortcuts: side, 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 angle, angle, and angle, angle, side. Thanks for watching. I hope this video was helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.